Hey there guys, this is Miss Doolittle, and this video is going to walk us through some synthetic division. Now, synthetic division should be a review for you. I know that Algebra 2 covers this, and we covered it before the pandemic started in March, and we had to go home for the rest of the school year last year. Synthetic division is something that you guys should have seen in Algebra 2, so I'm hoping that this serves as just a review for you. So let's go ahead and get started. In the problem that we have down below, you're going to see that the dividend, the number in the red, or the polynomial in the red that is being divided, this is a fourth degree polynomial, okay? I'm going to write this out for you real quick. What that would be if we saw that in normal format would be f of x is equal to x to the fourth minus x cubed, and then that 0x squared that you see there, we normally wouldn't see that, right? So I'm trying to point out the idea that we have to make sure we have all our placeholders when we divide. So what we would normally see is minus 2x and then the plus 2 up here. So this would be the original function that you would typically see. What we have to do when we write it in long division and in synthetic division is make sure that we have a placeholder there for any of those missing degree terms, okay? So the long division is on this side. We have that over here so that we can mirror that with the synthetic division, and you can see the similarities between the two, okay? So in synthetic division, what we're going to do is go in here and get all of our coefficients. So we're not going to worry about the variables or the exponents right now. We're just going to get our coefficients, and we're going to list those over here for our synthetic division. So this is a 1x to the fourth power and a negative 1x to the third power. You'll notice the x to the second power is not there, so I need to account for that with a 0. Then my x power has a coefficient of negative 2 and then a constant of positive 2. Then I'm going to draw this great big long L, like the capital letter L with a big long foot on it. And then outside the synthetic division box, okay, where the divisor goes. In long division, we use the factor, that x plus 1 factor. But this time what we're going to do is use the root or the solution or the 0. Remember, all three of those terms mean the same thing, that goes with x plus 1. So remember, if we were to take x plus 1 and set it equal to 0, we would solve that by subtracting 1 from both sides, and we would get x equals negative 1. Well, it's the root or the solution or the 0 that we're going to use as the divisor in our synthetic division. Okay? Now, the first step in synthetic division is we are going to drop our very first value. Okay? So nothing mathematical to do to it. You just drop it straight down. Okay, now I'm going to multiply. Negative 1 times 1 is negative 1. Now I am going to add in the second column. I'm going to add these values here. Negative 1 and negative 1 is negative 2. I'm now going to multiply again. Negative 1 times negative 2 is positive 2. Add these guys together, you get a 2. Multiply again. Negative 1 times 2 is negative 2. And I'm going to add again, negative 2 and negative 2 is negative 4. Now negative 1 times negative 4 is positive 4. And then when I add the 2 and the 4 in the final column, I get a 6. Okay, so the mathematical part is done. That actually is the synthetic division process. Now, we do have to know how to express our answer, though. Okay, so what this means, since we took a fourth degree polynomial and we divided it by a linear term, or in other words, a first degree, right? That means these values that are down here represent, their coefficients representing the next degree, the next lower degree term, okay? So instead of a fourth degree polynomial, we're now going to be working with a third degree polynomial. So what this really represents is 1x to the third power minus 2x squared plus 2x minus 4. And then what my 6 represents, and I usually put another L around that 6, that represents my remainder. So that's going to be 6 over x plus 1. So when you take your remainder and put that over top of your divisor, that is the proper way to express that. So a couple of things I want to compare here. Here's my x cubed, negative 2x squared, negative 2x squared, plus 2x, minus 4, minus 4. Then they show us down here, we have our remainder of 6. They don't really show that in written out format until we get down to this answer at the bottom. But the point that they're trying to make here is either way, when we take x to the 4th minus x cubed minus 2x plus 2 and divide by x plus 1, either through long division or through synthetic division, we are going to get this exact same value. Okay? Now, here's the thing. I know for me personally, I have always been more fond of the process of synthetic division. I think it's easier to keep track of. However, there's a caveat, and we're going to get to this at the end of the video. You can only use synthetic division in certain circumstances. Okay, so if you're just like loving the idea that synthetic division looks a little easier, I agree with you on that. I think the process looks easier, but remember, there's only certain times that you can use it. And I'm going to bring that back up in just a little bit. Okay, so now on this problem, we're going to do another example together, and I'm going to tell you ahead of time, the numbers do not work out nice on this one. I had to stop and check myself the first time I worked this problem out because the numbers didn't play friendly. So at any rate, let's go ahead and get this thing set up. We're looking at a 5th degree polynomial, right? So I'm going to start taking my coefficients, 3 for my x to the 5th term. I do not have an x to the 4th term. That means I have to put a 0 there because that's 0 x to the 4th. Minus 2 x to the 3rd. So I'm going to write down a minus 2. Plus 1 x squared. So I'm going to put a 1 there. Plus 0 x's. I do not have a linear term there. No x to the 1st power. So I've got to fill in a 0 again. And then my minus 7 is my constant. Okay. L with a great big long foot. And then because my divisor is x plus 2, I am going to use the root or the solution or the 0 that goes along with that. Remember, that's just taking the opposite of what's here. So instead of positive 2, I'm going to have a negative 2 there. Okay? Now, I keep getting behind on my steps here, but step number 1, list the coefficients of the dividend. That's this big long function, including zeros for placeholders as needed, and we did that. Number 2, list the root, the solution, the 0 associated with the divisor outside the synthetic division box. So remember, negative 2 is the root or the solution or the 0 that goes along with this factor of x plus 2. Okay? All right, now we have to drop the first term of the dividend. So I'm going to take my 3 and I'm going to drop it. And I can just draw my line there because I know I'm going to be using it. Step 4, multiply the divisor, negative 2, and the dropped term, 3, and place the value listed in the second column. Place the value under the value listed in the second column, pardon me. Negative 2 times 3 is negative 6. So now we're going to add those. 0 plus negative 6 is negative 6. And then down here, add the values. That's what we just did. Now step 6 says just keep repeating steps 4 and 5. So keep multiplying, adding, multiplying, adding, multiplying, adding until you're done, right? So negative 2 times negative 6 is 12. Add, I get 10. Negative 2 times 10 is negative 20. Add, I get negative 19. Negative 2 times negative 19 is 38. Add, and I get 38. And negative 2 times 38 is a 76, I believe. So a 76 is going to go here. That's going to be negative. Negative 7 and negative 76 is negative 83. And remember, that's the one that I put the other box around because that is my remainder. So that means this answer, since I started with an x to the 5th function, a 5th degree, that means my quotient is going to begin with an x to the 4th. It's going to be a 4th degree polynomial. So this is 3x to the 4th power minus 6x to the 3rd, pardon me, plus 10x squared minus 19x plus 38 minus 83 over x plus 2. Okay, so this would end up being my full quotient, remainder included. Okay? All right. And that last part that we just did, by the way, is step 7. Okay, now, I'm going to give you guys just a minute, or actually I don't have to do that because you can press pause. So I'm going to ask you to press pause and try to work this thing out, and then we will work it out together as soon as you get back. All right, welcome back. Hopefully you had a chance to work through this problem. You can check your answer right down here. I went ahead and wrote this out for you. Notice we're going to take our 2 coefficient for the 2x cubed. I have a 0x squared, negative 1x, and a 3. And then my x minus 1 divisor is going to be a positive 1 divisor in synthetic division. Okay, so go through the process. These are the coefficients that I get for my x, my quadratic term, my x squared term, and that turns into this particular polynomial function as a quotient. Okay. All right. Now, we're going to look at one different type of problem, and then I have just like another thing to sum this whole process up for you. Again, I'd like for you guys to press pause. Take another stab at doing one more problem. This one's numbers should play pretty nice. So go ahead and press pause. We'll check whenever you push play again. Okay, welcome back. I'm going to go ahead and work this one out step by step with you. So inside the division box, we are going to have a 1 for my 1x cubed, negative 3, negative 6, positive 8, no placeholders there. We have all of our terms accounted for. Then my x minus 4 divisor is going to turn into a positive 4 as a divisor for my synthetic division. Drop the 1. 4 times 1 is 4. Add these guys, I get positive 1. 4 times 1 again is 4. Add these guys, I get negative 2. 4 times negative 2 is negative 8. When I add positive 8 and negative 8, I get 0. Now, the reason I wanted to wrap up with this particular problem, let's go ahead and write down our quotient function here. So it's going to be x squared, since we started off with an x cubed, this is going to be reduced by 1 degree. So x squared plus 1x minus 2, and I have no remainder to deal with here. The reason I wanted to end on this type of a problem is because when we have a 0 remainder, we know that x minus 4 is in fact a factor of our original polynomial function, okay? So when there's no remainder, or when your remainder is 0, is probably a better way to say that. When your remainder is 0, that means the divisor is a factor of the polynomial function that you started with, okay? So to write this completely, I would say x cubed minus 3x squared minus 6x plus 8. This is just to show you the whole idea. This is your answer, by the way. That has not changed. But when we take the original polynomial and divide by x minus 4, we do in fact get x squared plus x minus 2. Another way I could write that is I could say that x cubed minus 3x squared minus 6x plus 8 is equal to x minus 4 times my quotient, x squared plus x minus 2. Okay, so we can see that this thing actually breaks down into these 2 different factors, and now this factor is a quadratic. So hopefully that's helping to open some memory files there from Algebra 2 as well, and help you guys remember how we break these things down. Okay, now the one last thing that I want to end with here. When do you use synthetic division? It is very, very specific. You can only use synthetic division when your divisor is linear. Okay, so you must have a linear divisor. That's the one that goes outside the division box. And its leading coefficient is a 1. Okay, so if you're dividing by like 2x plus 3, technically we could do that, but we have to do some things to it first to make its leading coefficient be a 1. So it has to be a linear expression that you're dividing by, so that means it can't be an x squared type of thing or an x cubed or anything like that. You have to use long division for those. We don't have any other way to do that. But if it's linear and its leading coefficient is a 1, then you can use synthetic division. So if we go back and look at this, linear divisor, leading coefficient is a 1. Let's look at the previous slide. Linear divisor, leading coefficient is a 1. Linear divisor, leading coefficient is a 1. Okay, so those are the two requirements that have to be in place in order for you to successfully use synthetic division. Okay, all right, guys, if you have any questions, let myself or Mr. Sickmiller know, and we'll see you in class. Bye-bye.